The role of food nutrients in reducing oxidative stress linked to microplastics.
By Dr. Joseph Mercola.
Here is what we are covering in today's explainer. 1. The invisible plastic invasion. 2. Cellular rust and diabetes. 3. Breaching the brain barrier. 4. The NRF2 defense switch. And finally 5. Your dietary action plan. We're going to dive really deeply into the hidden biological mechanisms of plastic accumulation in the body, and then we'll arrive at some highly actionable, nutrient-based solutions. Section 1. The invisible plastic invasion. The scale of the invisible threat. You know, for decades, we've all been warned about visible plastic waste, right? The bottles floating in the ocean, the plastic grocery bags piling up in the landfill. But the narrative has entirely shifted. We are no longer just dealing with a macro environmental waste problem. We are dealing with a direct microscopic cellular threat. These plastics are breaking down and degrading into microplastics and nanoplastics, and they have thoroughly infiltrated the food we eat, the water we drink, and literally the air we breathe. Cumulative global plastic production is expected to reach an absolutely staggering 33 billion tons by the year 2050. To put that massive number into perspective, as production increases to roughly 400 million tons annually right now, our everyday inescapable exposure to these microscopic fragments is skyrocketing. And the thing is, these tiny particles don't just pass through our digestive system and quietly leave. The absolute smallest of them actually lodge themselves deeply into our tissues. Completely avoiding exposure is unfortunately no longer a realistic option for anyone. Section 2. Cellular rust and diabetes. Metabolic disruption in the body. So what happens when these microscopic plastics accumulate in vital organs that are responsible for blood sugar regulation? I'm talking specifically about the liver, the pancreas, and the kidneys. Well, they trigger a biological reaction known as oxidative stress. Think of oxidative stress quite literally as an internal rust. When you expose a piece of metal to the elements, it slowly oxidizes, right? It breaks down. Inside your liver and pancreas, microplastics cause these damaging molecules called free radicals to accumulate way faster than your cells can neutralize them. And over time, this silent rusting process wears down your organ tissues, creating a state of chronic inflammation. Now, size absolutely matters here. The reviewed research highlights a really fascinating deep dive finding. Nanoplastics measuring just 100 nanometers produce significantly greater cellular toxicity than larger microplastic particles. Because they are so incredibly small, they easily slip right through the biological barriers that are meant to protect us. At just 100 nanometers, the body's natural filters simply don't even register them as foreign obstacles until the inflammation has already started. In animal studies, these microscopic intruders have been shown to drastically increase liver inflammation, they intensify fat metabolism problems, and they completely disrupt the delicate balance of beneficial bacteria in the gut. Let's actually compare the known biological changes of type 2 diabetes with the effects of microplastic exposure. In experimental animal studies, researchers have found something wild. Exposure to polystyrene microplastics and nanoplastics actually mirrors the exact physiological damage that we see in diabetes. The exposure directly increases insulin resistance, which means the cells just stop responding efficiently to insulin, and it severely worsens glucose tolerance. In essence, that plastic-induced rust forces the body to keep blood sugar levels elevated, which damages the metabolic system long before any clinical symptoms of diabetes ever appear. Section 3. Breaching the brain barrier. The path to cognitive decline. A review published in the International Journal of Molecular Sciences shifts our focus to an even more alarming reality. Remember how small those nanoplastics are? Well, they are small enough to actually penetrate the blood-brain barrier. That is the highly selective protective filter that normally shields our brain from harmful substances in our bloodstream. Now, we know type 2 diabetes is insulin resistance in the body, but when nanoplastics trigger oxidative stress and inflammation inside the brain, it leads to brain insulin resistance. In fact, some scientists informally call Alzheimer's disease type 3 diabetes. Your brain consumes enormous amounts of energy, and this brain insulin resistance actually stops your neurons from efficiently using glucose for fuel. The brain cells essentially begin to starve, and this localized energy crisis is a foundational step toward cognitive decline. Let's walk through the timeline of how quickly this actually happens, based on laboratory and animal research. It's a pretty vicious accelerated cycle. On day 1, nanoplastics managed to enter the brain tissue. By just day 7, exposure to 80 nanometer particles was shown to disrupt learning and memory in mice. That is incredibly fast. Over the ensuing months, the microglia, which are the immune cells that are meant to protect the brain, they become overactivated. They shift into a chronic inflammatory state, constantly interfering with nearby neurons. Over years, this compounding oxidative stress severely weakens your antioxidant defenses, completely starving those neurons of energy and eventually promoting the formation of beta-amyloid plaques and tau tangles, which are the classic, undeniable hallmarks of Alzheimer's. To really underline exactly why this happens, healthy brain cells absolutely rely on highly specialized glucose transporters to move energy across that blood-brain barrier. But plastic-induced inflammation, along with aging and insulin resistance, physically reduces the activity of these vital transporters. This creates a severe cellular energy shortage. And here is the major key takeaway. This energy deficit affects your concentration, your working memory, and your overall cognitive performance long before any obvious outward symptoms of dementia ever appear. Section 4. The NRF2 defense switch, your body's internal alarm system. Okay, so we have thoroughly mapped out the problem. But here is the good news. Your body is not defenseless against this invisible invasion. The biology of your cellular rescue team relies on something called the NRF2 pathway. This is your body's master switch for antioxidant defense. Most of the time, this protein just sits idle in your cells, waiting. But when it detects cellular stress, like the oxidative damage from a nanoplastic, it trips the alarm. The NRF2 protein physically moves into the cell's nucleus and flips the switch on a vast, protective network of genes. These genes immediately get to work producing detoxification enzymes to neutralize those harmful free radicals and start repairing tissue damage. So how exactly do we trigger this master switch? Well, we do it through specific plant-derived nutrients. These compounds essentially act as chemical keys that activate NRF2. For example, there's ursolic acid, which you'll find abundantly in everyday apple peels, berries, and herbs. Then there's verbascosidae, found in lemon verbena and mullein. You also have diosmin. Now this one is densely concentrated in the white pith of citrus fruit, which is wild because that's the exact part most of us peel off and throw in the trash. Add to that biocolin, extracted from Chinese skullcap roots, and cynarin, a major protective compound found in artichokes. These aren't just generic vitamins, guys. These are highly precise biological tools that strengthen your brain against those exact insulin signaling problems we talked about earlier. And the targeted impact of these compounds is really remarkable in the laboratory research. When you consume ursolic acid from an apple peel, it doesn't just reduce general inflammation. It has been shown to specifically reduce beta-amyloid toxicity in the brain. The diosmin from your citrus pith actively boosts those antioxidant defenses and has been shown to improve both working and long-term memory. The cynarin from artichokes directly lowers the accumulation of tau proteins. By actively feeding your body these specific polyphenols and flavonoids, you are quite literally interrupting the progression of cognitive decline by preserving glucose uptake and turning on your most powerful cellular defense networks. Section 5. Your dietary action plan, building long-term cellular resilience. Now, understanding the biology is only half the battle. Since complete avoidance of environmental plastics is no longer realistic, we have to actively build our internal resilience. Here's the comprehensive 5-step action plan derived directly from the source material. It's designed to help you methodically lower your ongoing daily exposure while simultaneously flooding your body with the exact nutrients required to support your NRF2 protective systems. Let's break these down step by step. For steps 1 and 2, start with what you can actually control. Ditch the plastic water bottles immediately. Switch to glass or stainless steel. Stop heating your food in plastic containers. That one change instantly reduces the raw volume of microplastics your body has to process every single day. Next, build your meals around a diverse array of those NRF2 activating foods we just discussed. Eat the apple peels, eat the citrus pith, incorporate artichokes and fresh herbs into your diet. Choose real plant diversity over heavily packaged processed products, which only bring more plastic into your system anyway. Moving on to step 3. Remember that your cells simply cannot run their antioxidant and detoxification systems if they are starved for energy. You have to support cellular energy production. The source specifically recommends supporting mitochondrial function by ensuring you get adequate protein, consuming enough carbohydrates, about 250 grams daily to support a healthy metabolism, and strictly avoiding seed oils, which can further compound that damaging oxidative stress. The crucial point for step 4 is tracking. Dr. Mercola specifically advises monitoring your HOMA-IR score rather than just looking at a standard fasting glucose test. HOMA-IR calculates the relationship between your fasting insulin and your fasting glucose. It shows exactly how hard your body is working behind the scenes to control your blood sugar. If your score creeps above 1.0, it is a major early warning sign of insulin resistance, often visible years before obvious symptoms appear. Keeping this score low means you are successfully limiting the inflammatory pathways that plastics exploit. And finally, step 5. The NRF2 pathway doesn't just respond to what you eat, it responds to how you live. Regular movement, high-quality sleep, maintaining healthy circadian rhythms, and getting consistent, natural morning daylight exposure all fundamentally support your cellular resilience. These vital daily lifestyle habits work hand-in-hand with your nutrition to keep your internal defense networks robust, healthy, and ready to clear out microplastic-induced oxidative stress. I'll leave you with this final question to spark some immediate action right now. What is one piece of everyday plastic you can replace today? Thank you for listening to another session of the Gemini Notebook.art series. You can find the full archive of all my podcasts at gemininotebook.art.